Okay, so for this first one, we have write the steps to calculate average atomic mass. What was one of the first steps y'all said? Yes. What, Chloe? All right, cool. So definitely one of the first things is move that decimal 2 to the left, right? But more importantly, what number do we do that to? Because what I saw in the test was people doing all of them. Which one? Relative abundance, good. All right, so it's the percentages, right? Okay, so on percent, which is the relative abundance, move decimal 2 to the left. Good. Okay. All right. So like I said, on the test, what I kept seeing was people did it to both of the values, or they did it to the mass and not the percent. So so let's make sure we're looking for the percents. All right, next step. What is it? Multiply. Who are we multiplying? Multiply it by, yes, so that I'm going to put individual mass, because what I ended up seeing was some people were taking, okay, we're taking the average atomic mass, so we gave you that information in the problem, like I think it was on the bonus one, and then they wanted to multiply these percent abundances by that number, and they did it for all of them. Okay, remember, we give you isotopes, okay? They're going to look like either in the table, they're going to be these special little decimals, so we could have like 32.5432, right? So we could have these long, complicated decimals. When they say isotope, okay, when they say something like sulfur 32 is this, right? What a lot of people did was if I gave you that information, you chose to use this number, and that's not what you do. You use that number as your last resort, okay? So preferably you need to use the most complicated number that's listed, okay? And then if we don't give you that, if we just give you a bunch of isotope names like this, then you can use that, okay? But first try to use the complicated number, okay? You kind of know what I'm talking about when I'm saying that. Like the problems had them all listed and crazy and stuff like that, okay? All right, and then finally, your third step. Add them. Good, so add them together. So good news, terrific news, great news is that I didn't see anybody divide. Yeah, and that was like my one goal, right? I told you guys that at the beginning of the notes. So, so nobody added them up and divided by 3, so I was happy about that, okay? But we do need to get better at this little skill. So like I said, we will put it on the next test. It will be on there for sure, okay? All right, the next thing, so you had sig figs, and some of us don't know what those are yet, so I do encourage you on Google Classroom to go back to the post that says Unit 1 Atomic Theory, and there's just a few little resources in there, okay? But for this first one, how many sig figs did we see in .00200? It's 3. It is 3, okay? So what was wrong with the first 2 zeros? They're leading zeros. We don't like leading zeros because we can always move that decimal and write it in scientific notation, right? What about the 2? What rule is that? It's a non-zero. Nope, not necessarily that. But it's a non-zero, right? Remember when I made you guys all shout out a non-zero number? Okay, right. So all non-zeros always count. What are these guys labeled as? Trailing zeros. And trailing zeros, who remembers what I said about trailing zeros? Like the decimal. Yeah, so only if there's a decimal. Good, so that was the important thing. But what did I tell you application-wise? Like why are those zeros actually important to us? What do they tell us if we're using a what to a what? You guys remember? Do you guys remember when I said that? Yes, yeah, it was when you either using a beaker or you're using a graduated cylinder, right? Okay, and so one is more precise than the other. We're going to see that a little bit today, okay? Okay. All right. So that one had 3. So number 2 had how many? This was 200. Has 1. That 2 counts. It's a non-zero, but these guys unfortunately do not because there's no decimal. Okay? All right. So we will be getting better at this. Sweet. Just a couple announcements. Okay? If you have already started checking out your grade and you notice that your lab safety grade is, I can't get that to move, but if you notice that your lab safety grade is a 50, it means that you're missing one of 2 things. So it's made up of 2 things. You had to do that yellow worksheet where you had to make a map of my classroom, right? And then answer the dress code kind of thing. This I need. And then the ed puzzle had to be done. So if you notice that you have a 50, one of those isn't done. And you can come ask me. I marked which one it is. If you have a missing on that, that means I didn't get either of them from you, and we need to talk, okay? Just get them in as soon as possible. That's your safety. We're technically doing our first lab tomorrow, but it's still not with super major chemicals. It's just H2O. Yeah? What? Okay, that was... Miss Vogel, you're so funny. All right, cool. All right, so so I do need you guys to get the safety stuff in because it is important, okay? All right, the quizzes. So I just needed to let you know that if your quiz grade seemed a little inflated, it might have been. I added 10 points for people who actually graded their quiz correctly. I had so many people just turn in a blank quiz. I had some people mark ones that were wrong, right, and the ones that were right, wrong. And so if you just take the time and grade it correctly over there, you got a bonus, okay? If you did not, then I gave you the grade that you got after I graded it, okay? So it's really important that you guys do that step because you can save me a little bit of time for having to sit there and regrade everything, okay? So I'm trying to help you out by letting you see what you got wrong right away, okay? All right, cool. Your little sticky notes. So this is what I got from them, okay? And so these are things that I'm going to try my best, okay, to do. I made sure these notes were a little more in order, and they're bigger, okay? I didn't get very many fill-in-the-blank requests, so today we have a little fill-in-the-blank, but the rest of it we're not going to be doing fill-in-the-blank, okay? The slowing down, I just have to stress, I can't. It's horrible, but we're stuck on this curriculum, and you guys have deadlines, and we have deadlines, and it sucks. It really sucks. This is a hard class, okay? But I'm here for you. So when you have that moment where you need me to slow down, that's probably your indication that you should come in for tutoring, hear it one more time, or watch the video one more time, and hopefully that'll help, okay? But make sure you ask questions. That's the biggest thing. Ask questions in class so that way everybody probably gets that question answered. Yeah. Yes. Sorry. I'm sorry. Okay. I'll add that to it. All right. Okay, cool. So, okay. So with your guys's notes, okay, we're just going to be filling these in. We're going to talk about accuracy and precision today. And then I'm going to move over and we're going to talk about percent error for a little bit. I'm going to go through this pretty quickly, okay? So just try to write down as quick as you can. And then on the, at the end of class, I want to grant you guys enough time to start your pre-lab so you don't have so much homework or any homework, hopefully, okay? Are we all clear? This is why I'm going to go fast. Okay, cool. So for this first part, so accuracy, it's the closeness of measurements and then your guys' paper says to the correct or accepted value of the quantity measured. And then you have a little room off to the right. I want you to write the word theoretical. Okay, because that's going to be the other word that you guys... Okay. So you might see this, especially my people who are going to continue on to physics. They usually use the word theoretical because you have to calculate stuff. Okay, so theoretical or accepted value. Precision is going to be the closeness of a set. Okay, notice more than one. A set of measurements of the same quantity made in the same way. Okay, so you guys being Chem 101, this is what's important to me. I know we're not going to always be accurate totally. Okay, we're not going to always get what we're supposed to get, but I do expect you, when you're taking multiple trials, to have precision, okay, to be precise. So make sure you are taking care of that, okay? All right, so you guys should have these little bullseyes, yeah? Okay, so the first one, bless you. The first one is to just show you what a bullseye, does everybody know what a bullseye is? I saw one shake. So what it is like when you do bow and arrow kind of thing and you're trying to shoot, or BB gun kind of thing, okay? And so you're trying to get where? In the center, right? So this is definitely where you want to go, okay? So in your first little circle, I want you to write accurate and precise down at the bottom. Okay, you should have a little line below yours. If you don't, you can write it above it or to the side. Okay. What did I say first? I meant second one. Sorry. Okay, is that better? It doesn't really matter as long as you label them correctly. Just like I said, the first one, I don't know why we have 4. Okay, so the first example we're going to look at is when something is accurate and precise. When it is accurate and precise, that means that we are going to be right where we need to be, okay? So it's going to look like that, okay? So we're right where we need to be, multiple shots, we can all get to the bullseye, okay? And they're grouped together, meaning that they're pretty consistent, okay? That's what I like to think of with precision, is its consistency. All right, if I have something that is precise but not accurate, it means I'm not going to be near the bullseye, but still my shots are going to be kind of all in the same area, okay? So I would still trust a person who is shooting this way, because what it could be is a defect on the BB gun or something to where it always goes to the right, right? But they can compensate for that and fix it, okay? But it's precise. They're still a good shoot, or shot, I guess you could call it. All right, but when we have not precise, not accurate, your data points are like, whoo, you might get one that's accurate, that's cool, but none of them are like close together. I don't trust you. Like, I don't want to be anywhere near this person shooting a BB gun, okay? And it might not be the person, it might be the tools. That's when you got to throw that BB gun away and get a new one. In here, that's when we throw away the balance and get you guys a new one, all right? So remember, your goal in your labs this year is this. Actually, this would be like the best. But you want precision, okay? You want consistency. Can I get a thumbs up, thumbs down on accuracy, precision? Do we think we've got at least the bullseye example? Awesome, okay. So moving on, you guys have a little table of data right there, okay? All right, so in this little table of data, you have to look at these numbers, and I want you to tell me what you think they are, okay? So if you read this, it says 3 students measured the length of a pencil whose accepted value was 19.1 centimeters. Ooh. So if that's what we're trying to get to, that means if we're going to be accurate, we're going to be close to that number. So student 1 got all of these values, and this is what the average came out to be. Is that accurate? 18.5. Is that accurate? No, okay, so not accurate. Because your average should come out to be what it's supposed to be, okay? Not accurate, but precise. Do you guys agree with my decision to say precise? Yeah, because they're all around the same value, okay? So they stayed pretty consistent. All right, student 2. Are they accurate? No. Are they precise? No. Okay, so they're neither. And then finally, student 3, their average comes out to be 19.1. Would you say that's pretty accurate?
Yeah.
Heck yeah. And looking at all their measurements, are they pretty precise?
Yeah.
Yes. Okay. And so that's what you're going to be responsible for looking at. Okay, we're going to probably give you questions where you're going to have those kinds of data points, or I'm going to ask you to analyze your own data. Were you precise? Were you accurate? Were you neither? Okay, so be ready to kind of analyze those kinds of numbers. How many of you guys actually used to use like accurate and precise like interchangeably? Like you say like, oh, that's really precise of you, or that's very accurate. No? Okay, good. Because I did. I used to. And then I became a science teacher, and I was like, oh. And I never put them together, and it bothers me when people do. And I'm like, they're not the same thing. But, yeah, it's a science thing. All right. Cool. So now we're at percent error. So this should just be below. You are filling in the blanks there with the red. Okay. Okay. So percent error is going to be a value calculated by Okay, so it's a value calculated by subtracting the experimental value, the measurement from the experiment. Okay, so I like to say this is you, all right? Remember how I made you write theoretical? This one is actually going to be named actual. And I have to tell you this because not everybody says experimental and accepted. It would be awesome if they did, but they don't. So this is the other word that you would be looking for. Actual is not accepted. It is what you got in the lab, okay? So it's from the experiment, okay? From the accepted value, which is the measurement given or expected, once again, that is theoretical. Okay? Difference by the accepted value, finally multiplying by 100. So what that means is you use that theoretical value, or that value from a book or what your teacher gives you. You use that one twice in this calculation. You only use yours once. Okay, so if you're using your number twice, you're doing something wrong. And you'll see what I mean in just a second. Okay, so I'm going to give you about 15 seconds, finish writing what you can, and then these will be posted, or you can come see me after. And this multiplying by 100 is because we are once again doing percent. Okay? Imagine that. So next, says that this value is used to find the accuracy of an experiment. Okay? Not the precision. Your precision is going to come from looking at your data and taking averages. Okay? Well, actually that's more accuracy too. But this one is for sure measuring how far off you were. Okay? So if the percent error is positive, then that means your experimental value was less than the expected. That makes sense because that's what's being subtracted, okay? If the percent error ends up negative, so if you came out with more than you were supposed to, then you're going to have a negative percent error. And in chemistry, this really isn't supposed to happen. It does, you will, but it's not really supposed to happen. So you kind of want to go back and just make sure your technique was okay. Because what it means is you contaminated something because you added extra chemicals in there that weren't supposed to be in there, okay? So, but what this means to you, and I want you to write this, leave the negative, okay? Happens all the time. People freak out when they get a negative on their calculator. They're like, well, I did something totally wrong. No. This is a good thing. This told you that you contaminated your project, which maybe isn't a good thing, but it's supposed to be there. So leave the negative alone, okay? We're all good? Okay. Go ahead and you turn your, actually no, before you turn your page, I want you to write something on this little equation, okay? So you guys have the little equation at the bottom of your page. I want you to write Next to accepted, what do we also call accepted? Theoretical. Okay. And doesn't theoretical kind of sound like a book, like technical and stuff like that? That's the way to think of it, okay? So that's the one that I have to give you. Experimental will sometimes be called actual. And people really like to put actual as accepted, and that's not what it is. Actual is what you did with your hands right there. You're comparing it to what it should have been, okay? As soon as you wrote those 3 words, go ahead and flip the page, and we're going to look at this problem together. Make sure we've got it, and then we should be set to do our pre-lab. Oh, yeah. You guys will be good. We'll have 10 minutes. Okay. So I have my little equation up there, so we'll just refer to that. Okay, this says, what is the percent error if the accepted value, okay, so accepted, is that the one from the book or from experiment like I did it? This is book. Okay, this is your theoretical. You don't have to put book if you don't want to, but this is the one that it's supposed to be, okay? Experimental is what you did, okay? Okay, so which number do we put first? 17.7 or 21.2? Nope, the 17.7, the accepted, okay? Accepted value. So we're going to put 17.7 grams minus, so you're taking the book value, subtracting what you did, so that was 21.2. You guys should have calculators, so you can even type this in as we go along. Okay, and my people who like to do everything in one step, make sure you use parentheses, and then you can put the divide, and I'll tell you the next step in a second. But what do you get when you subtract those two? Negative 3.5, is everybody getting that? Yeah? Okay. Negative 3.5 came from that, okay? So negative 3.5, you're just going to push divide. You don't need to clear your calculator. Just push divide. You're going to divide it by 17.7. Do you see that the book value shows up twice? Yours only shows up once. This is more important than you. Just kidding. You guys are important. I'm just kidding. But, I'm sorry. It's been a long day. All right. I thought it was funny. It was like a demotivational poster there. Like, the book value is more important than you are. All right. No, but so yours only shows up once. That's the big idea that I want you to get from it. Okay. Once you've done that, so now you've divided this by 17.7. What are we at now? 0.198. Okay, we're gonna go to 2 sig figs. See, now you guys know what that is, right? 2 sig figs, both of these count. Okay, and I'm gonna multiply that by 100. And actually, what is the third number? 7. It is a 7? Never mind, put the 7 on there. I don't want you to round it. Because looking through this, you don't know this yet, but you're supposed to follow whatever they give you. So there's 3 sig figs given to you. You should end your answer with 3 sig figs. Okay? So we're actually going to do that. 0.197. And now we're going to multiply that by 100 to make a percent. What is the other thing you can do without typing it into your calculator? Move that decimal 2 to the right. Exactly. So we're doing opposite of what we were doing. 19.7. And it's negative, so does that mean I was above or below? Above value. You contaminated your experiment, most likely. Okay? Okay, so I'm going to shrink this up so you guys can see it in the back. Copy down what you need to copy down, and then we're going to move on to the next page. Yes? Okay. So we'll come back to density after you guys do the lab, probably. Okay? Right. You should be looking at this page now. Discovering density. So this is your first formal lab write-up. Those of you in AP Bio, you've already started doing your formal lab write-ups. You know how it goes. So this is just extra practice for that. And Everyone else, we're learning how to write it, so I'm not going to be as strict as your AP Bio lab reports, okay? I got that question this morning. I was like, no, I won't. I mean, I'm going to be strict, but not that strict yet. All right. So when you guys do this, okay, the most important thing here is that I told you to read this. Yes, that means you need to read all of those words. Pay attention to the stuff that's underlined. Those are important facts, okay? You do need to read all of that. Then you're going to be answering 1 through 5. Those are the questions. Most of them are like 2 to 3 words, so you shouldn't have too much of an issue. And then you're going to copy the objective. Does everybody see the objective? Yes? Okay. You're going to just copy it word for word. In future labs, I'm going to make you write your own objective. Okay? And then I am giving you the option to either cut and paste the data table from below. I made it so that you could cut it off. Or you can draw it into your lab journal. Preferred, like the preferred way, is to draw it in so that you don't have things that are potentially going to fall out and stuff pasted in like that. But I'm giving you the permission to cut this little data table off and tape it in there, okay? Okay, I need all of this by tomorrow. So that's why I'm going to give you the next 10 minutes to kind of get started with people around you. The setup in your lab book is going to be like this, okay? So start with your name always. That way you don't ever turn in a lab without your name. Then you're going to put your little title. You're going to list out your pre-lab questions, write your objective, and then data table can go on the next page if you want. That way it's next to where you're going to graph, okay?